Hello. So today we are going to start the chapter Dictionaries and Sets. Let me just share my screen and get started with the REPL that I'm going to be working on. So this is my REPL, and I can go to my instructor handle, which is at Uchiroda, one word. And then in all of these REPLs, I'm going to pick the one that we're going to do today, Dictionaries and Sets, and I'm going to fork it, and I'm not going to change the name or anything. So it's going to create a brand new REPL for me that I can work on. So, so dictionaries, what are dictionaries? Dictionary is an object that stores a collection of data, just like a list. Some might ask me, Miss Suchi, we already have a list, a data structure called list that does the exact same thing. So why do we also need dictionaries? Well, I'm glad you asked. Dictionary has keys and values. Wait, hold on for just a second. So before I even tell you what a dictionary is, what a key and a value is, let's backtrack to what a list was. So we have seen some lists in our previous chapters. So for example, if I have a list called student, and it had two elements, two strings, Mary Kay and Kate, so I was able to store student data using a list. So if I try to print it, it would tell me that Mary Kay was at index position 0 and Kate at Ulam was at index position 1. So basically, while it looks like a list only has values, in the background, what Python is doing is it is assigning them some indexes. So if I add a new element, say major, to this list, then it is appending. All I'm having to tell it is the value, and it is deciding where that value is going to go, and it is assigning a numeric index value to it. And this worked for us so far, but there are some scenarios. So for example, what if I have another student, let's call him student one instead. And so let's say they have a name, say James. And then say, for example, I don't know their email address yet. Okay, so I'll have to force. And what if I don't even know their major? All I know about this student is James. And then I don't know their email address. I don't know their major. So because I'm using a list here, say, for example, if I know their major, COSC, and but because Python needs to be consistent, we need our second element to always be an email address. We have to put some element with a blank in there, and then we can use major. So imagine if a data element, if a student had 100 data elements, and they may not have values for all those hundreds. So if I want to create a new student with only those specific values, then I'm creating a lot of blank spaces in my list, which is not necessary. Realistically, we shouldn't have to do that. So that is why, and also second reason is 0, 1, and 2 makes sense to Python. But as a human being, wouldn't it be better to have something like, well, 0 instead of 0? Why can't I call it name for what it is? And why can't I call this email? So wouldn't it be an ideal scenario? Here, instead of 0, I have an index called name, and then that will become easier. So that is the difference between a list and a dictionary. So given this list, say if I want to convert this list to a dictionary, number one, I would have to take off the square brackets and I would have to put curly braces. That's step number one. Step number two, now I have to tell the index. So I'm saying name because that makes sense to me. And then all of these are comma separated elements, so that's not going to change. Now I have to specify the email address. So that's the change that I can make to a list to make it into a dictionary. And now if I print it, now it's not going to be 0 and 1 anymore. It's name and email. So, well, how to create dictionaries? What are the syntaxes? We will see that in just a second. But that is the difference between a list and a dictionary, because both of them are objects that collect data in a sequence. But the difference is dictionaries also have keys. So we now have the responsibility of specifying a key with a colon. All right, so that was this part that I just did. So So curly braces and colons. The moment you see curly braces and colons, we know that that's a dictionary. So let's get to the next. So the characteristics. What are the characteristics of a dictionary? So we have learned in the very beginning that three characteristics define whether a data structure should be a dictionary or a list or a tuple. Because as a programmer, you should know when to use a list, when to use a tuple, when to use a dictionary, because all of them happen to be sequences. So for example, the first characteristic was mutability. So we have seen in our list chapters that mutability means change. You can mutate the data structure, as in when the list is created or after the list is created, can you add elements to it? Can you delete elements from it? And so on and so forth. And yes, we saw that lists were mutable. And tuples, however, you can, once a tuple is created, we could not modify a tuple. So tuples are immutable. Similarly, this data structure, dictionaries, is a mutable data structure, as in once you create a dictionary, you can add or modify elements. And how can we do that? We'll see in our next chapters or next sections. So I want you to bring your attention to immutable data types. Yes, we've seen tuples are immutable data types, but if you think about it, integers are also immutable. Once you create them, you cannot, the only way to is destroy that and create a new variable. And strings are immutable, booleans are immutable, floats are immutable, and tuples are immutable. So far we've seen lists are the mutable data structures, dictionaries are the mutable data structures, and then next section we'll see sets also, and sets are also mutable data structures. So that is one characteristic, is mutability. Next is order. So what do we mean by order? So remember from our previous chapter, we said lists and tuples are ordered. So let's see what that even means. So if we have two students or the same student, the data structure elements are ordered differently. So here, Mary K is in the index position 0 and K is at index position 1. And let's just say if I print these two, so that's what student 1 shows me that 0 is Mary K, 1 is K at ulm.edu. And similarly, if I print 2, it will print this list. So if I try to compare, again, as a human being, to me, they're the same because they both have the data of the same person, Mary Kay and the email address. The data is the same, but they're just flipped. So according to Python, is that same or not? If I try to print that, so I'm going to compare, hey, is student 1 equal to student 2? That means if they are equal, that means they are the same data structures. But Python says, if I can wait for just 1 second, it says they're not same because according to Python, if you provide student one's index as 0, and if the value is the same as the student two's index position 0, then only they're the same. Otherwise, they're not same. But now let's look at how dictionaries are going to work. So well, spoiler alert, dictionaries don't care about order. They are unordered data structures. So for example, I have student called Mary Kay. Her name and email are specified here, but I flip for student 2. I'm saying email is first and then comes name, but the values are the same. I haven't changed the values. The value for name is the same here, and email is the same here and here. And if I try to do the same comparison here, is that going to say it's same or not same? Well, Python says they are the same because Python does not care the order in a dictionary as long as if you specify name in this student and specify the name for this student, if they retrieve the same value, then they're the same. So they don't care about order as long as the keys are same. So if I add another element with another key, then they're not the same anymore. But all things the same, just the order is different. Dictionaries are unordered data structures. So that's the second characteristic. What is the third characteristic? And that is duplication. So can data values be duplicated? So when we saw lists chapter, we saw we had some scores, let's say 56, 78, um, 99, so on and so forth. Can we have another 99? Yes, we could. So duplication was possible in lists. So here in Python, duplications of values is possible, but you cannot have a duplicate name. So for example, if I do something like this, Python is simply not going to like it. It's like you already said the name was going to be this, and now you're saying name is Mary Ann. So what it's going to do is it is going to overwrite Mary K with Mary Ann because that is the next, this is the latest information you're giving it to in a dictionary. So it's not Mary Kay anymore. But as you see, we have defined a dictionary with 3 elements, but when you try to print it, there's only 2 elements. So duplication, as far as keys goes, you cannot have duplicate keys in Python in a dictionary, but you can have duplicate values, and we will see all of that in just a second. So points to take away, dictionaries are mutable, dictionaries are unordered, and dictionaries can have duplicate values, but they cannot have duplicate keys. So again, it won't give you an error if you define a duplicate key. It'll simply override the existing value. So, all right. Without further ado, let's get to creating a dictionary. So we have seen in our lists how to create an empty list. So how can we create an empty dictionary? The syntax is you provide the dictionary name and then you give it an equal to, and then you open close curly braces. Or if you use the DICT method with open close parentheses, you can create an empty list. So there are 2 different ways to do this. So open close empty curly braces, or equal to DICT and open close parentheses will create a brand new empty dictionary. So if I try to print this using the print method, it will tell me that there's no elements in there. Well, actually, yeah. So it'll just simply tell me that it's an empty dictionary with no values in there. So remember when we did lists, how did we do lists? Instead of curly braces, we simply did square brackets and then we used the list constructor. Okay, so there we go. That is how we create a list. So how about a tuple? We did parentheses. Well, we had to put a parentheses, and then we had to put a tuple. So 2 different ways of creating an empty tuple was using parentheses or using the tuple constructor. So similarly, dictionaries curly braces and the DICT method or constructor. So one thing I want you to remember from this point on, what I'm doing when I do this, or when I do this, or when I do this. So if you look at it, the syntax for all of these are very similar. So what I am doing, according to Python, is I am creating an object named student of the DICT class, or I'm creating an object of student of the list class, or I'm creating an object named student of the tuple class. And we will see what object and tuple and all of those in our next lectures. But I want you to remember that we created student as an object of the class dictionary. So anytime you see that code, you need to be able to tell me that. Okay, fine. We have created empty list, but how can we create dictionary with values? Empty dictionary is no good to me. So there's method 1. So one method is we can specify a key. In this case, it happens to be a string, a colon, and another and a value, and this happens to be another string. So and a comma. So if I want to define more elements, I would use a comma and I would say, okay, second element has a key value pair, and the key value pair is always separated by a colon. So here I've added this element. It makes no sense really, just to show that indexes don't necessarily have to be strings. They can be an integer also. In fact, they can be any immutable data structure. So they can be integers, they can be floats, they can be strings, and they can be a tuple also. also, and a boolean also. So as long as it is immutable, you can use that as a key. It doesn't have to be a string. And the values can be literally anything, any data type, integer, string, boolean, float, or a dictionary list, tuple, dictionary inside a dictionary, list inside a list, tuple inside a tuple, or any probable combination. So values, anything works, but keys just have to be immutable. So that is one thing I want you to take a look. And there's a closer look for you if you want to go back and look at it and how to define a dictionary with values. So method two is first, we create an empty dictionary. So we already know how to do that. Open close curly braces or DICT, open close parentheses will give me an empty dictionary. And then once I create the dictionary, then I can use the same square brackets that we've used in lists and tuples to create indexes. So now the key will go inside those square brackets. And again, it happens to be a string. So that's why I put it in single quotes, and then the value goes on the right side of the equal to. So I'm assigning Mary Kay to this index in this dictionary's key, which is name. So if I want to do CWID, then I would do it like this. So if you want to, um, and I would like for you to try and see, this was our original dictionary, the name CWID major GPA. So I only added two elements. Can you add the remaining elements, the major, even the three and the GPA and C, and then print your dictionary and see? Or if you don't know how to do it, the answer is provided. So that was another method. So there's another third method, and that is using the DICT um, class. So first, this list, let's see. So the parentheses are empty in DICT. So far when we created an empty dictionary, the DICT had empty parentheses, right? But the ICT is versatile where it can also take parameters. So what happens when you pass it a parameter? And that's what we're going to see. So the syntax is it'll create a dictionary using the DICT method if you pass it a list. That's the caveat. So I have to, let's see, step one, I have to create tuples with two elements, key and value. So if I have Mary and name as the key, then I have to create a tuple for that. And it has to be name and the value because name is the key, right? And then major and CWID is that. And then major is CINS. So that's the first. So I'm only creating two elements for now, just for demonstration purposes. Second step, once I have these two tuples, I have to create a list with these two tuples. So the first element of the list would be the first tuple, second element will be the second tuple. Third, we're not done yet. This is still a list. When we pass this list to the DICT method or DICT class, then it becomes a dictionary. So when I print it now, it's going to create that dictionary with the name and the CWID as the keys. So if I wanted to add another element, so I would create, say, major. Let's say major tuple is equal to, I have to create a tuple, and beware, this one must exactly have two values. It cannot have one, it cannot have three, it has to be exactly two. So if it is not two, then Python is not going to know what to do and it's going to throw an error. So this is the key, this is the value inside a tuple. And now to this list, I'm going to add my third tuple. And now if I try to run it, it's going to print the major also as a third element of the dictionary. So I'm going to break my code and show you if I give it 3, then Python says I'm not able to unpack. I was only expecting 2. You're giving me 3 and I don't know what to do with the third one. So key value pair always, it's a pair. So no more than 2 here. So that's the one thing to remember. So again, step one is to create individual tuples. And you know me, I like to do it like this. How about why create brand new variables when you can do it all in one step? So instead of major tuple, so I have 3 tuples here. And then all of them in one single list. So I don't even need this anymore. And also Hey, why do I even have to create another variable called student list? Can I just not pass the whole thing to the dictionary method? Yes, I can. So I can do that also. So when I do that, it'll still create me the dictionary. Again, if and when you're ready to do that, do that. Otherwise, you can do step one, step two, step three, and that will still be okay. So that was method three of how to create a dictionary with values. And I have given you a try block where you can see, can you add all of these dictionary elements using the third method? So try it. If you don't know, the answer is provided. So let's jump to the next section. So all right, we have our dictionary. We have created our dictionary. Now, how can we access the values of this dictionary? So let me go back to a simpler example. And I say I have a dictionary with how many elements are these? One and two elements. And if I want to get the CWID of a student, I simply put the square brackets that I have used, the same thing in lists also. And in lists, we provided it an integer value like a 0 or a 1. Here, I can simply say CWID. Isn't that more human readable? So I'm storing this value inside value and I'm printing the value and it'll print me just the CWID of that student. So that is one way to access the student's uh, key using the key. Only problem here is if the key is not found, Python raises an exception. So for example, if I want to print the major of this student, then Python is going to say, whoa, I only have name CWID, but you're asking me for a major. So it says key error, which means I did not find the key. So we have to handle a situation like that because, in our real life situation, some students will have some values, other students may not have those values, those keys defined. That was the whole point of us moving from lists to dictionaries is we don't want to force a student to have every single value. They can have one, two, or none at all, and our codes should still work. So in this situation, how do we handle this? So right off the bat, you can tell, hey, that's an exception. So you can use exception handling and try. And instead of this, I can simply put it in a try. So in a try block, I'm going to try to print the major. If an exception is raised, it'll simply say key not found. So that's better. Or I can use the in operator. Again, we will see this again in the next section, and we'll see if major, not in dictionary, it's student. So if major in this student, then only print the major, else don't say key not found. So we can simply look for is major in student and it's going to look, no, it's not. So it's going to print key not found. So that's another second way of handling. Anytime we try to access an element, we have to first check is the corresponding, is it even in the dictionary? Because if it doesn't, then our code is going to break. The last way of doing it is simply, very simply, instead of using indexes. So we're getting away from the list mentality of using square brackets and an index inside the square bracket. We can simply use a method in dictionary and we simply say dictionary name, which is student, and say we dot get. Simply, hey, from student, get me major, right? Simple plain English. When I try to do that, without any in operator or exception handling, it's just going to print me none because it didn't find the major, so it said none. So that's another way of doing it. So three ways of accessing data elements in a dictionary. And all right, so we were able to access elements from an existing dictionary. What if I want to modify those elements? I know um, that if I want to update somebody's name, they could be a name change, they got married, their last name changed, they want to change their name, or there was a typo in their original name and we want to change it to something else. So how can we modify the elements of a dictionary once it's created? So let's say we have our original dictionary with only two elements, name and CWID. The way to, let me just comment that out for now. if I want to change the name John Decker, say to Josh Decker, say, hey, there was a typo, I want to update it to Josh Decker. And then if I try to do that, I have to use the square brackets. Again, square brackets will always give me the index or the key of any data structure. We have done that in list, we have done that in tuples. We can use the same concept here in dictionaries. And then if I try to print my dictionary, now my dictionary has the new name as Josh Decker. And what happens when I try to do this? When student square brackets major COSC, what is Python going to do at this point? Is it going to say, oh my gosh, I don't have the key major, what am I going to do? And throw an exception? Or is it going to simply create a brand new key value pair? And that's what it did. So if you try to have an existing key and you change the value, it'll update the value. If the value doesn't exist, if the key doesn't even exist, it will create the key value pair. So that is how we change the value given a key. So if we know the key, hey, I want to change the name. So here is the key that I want to change. Then you can easily change it using the square brackets. But what if somebody said to you, hey, I don't know what the key is, but I want you to change the name or from John Decker to Josh Decker. So if I didn't know as a programmer what the key was, then how do we do it? So let's see. There is no way, if you don't know the key, then you have to go over the dictionary using a for loop. So we will see this in detail using the for loop in a little bit detail later on, but bear with me for just a second and let's see how we can do it here. So if I have a dictionary name in CWID and the user is telling me I only know the old name and I want you to change it to new name, then we have to use a for loop. So this is how we use a for loop in Python. So let me break it down here. In lists, we only had one loop variable, or we could have two if we had enumerate. Okay, so let's let me try to refresh your memory here. So for lists, we did something like this. If I can, did I spell it correctly? And if that was the existing list. Okay, so I'm just going to do pass. I'm going to say list is just a simple empty list for now. Okay, so we used an enumerate function to operate on a list, and that gave us the key and the value. And the key is always 1, 0, 1, 2, 3, so on and so forth. And value is whatever value is specified here. So in this case, if I do 23, 45, 56, and I print key and value here, it would print me 0, 23, 1, 45, and so on and so forth. So let's do that. I'm also going to comment that out. I don't want that. So we're just going back to our basics. So this was our list. So 0, 23, 1. Very similarly, we can do something like that in a dictionary also. The only difference is we don't have an enumerate. Instead, we have a method called items. Okay, so the dictionary name comes first. Here, the dictionary name, the list name was inside the parentheses, but here it is outside the parentheses and a dot, and then items with open close parentheses. So whenever you see something like that, so remember what we talked about earlier, that student is an object of the class DICT. So now this is an object. So anytime you take an object and you put a dot next to it and then you use a function, that's called a method. So we will see all of that in the classes and the next chapter of class object-oriented programming. So I'm going to clear out everything and let's go back to our original example. So the user says, I know that I want to change John Decker to Josh Decker. So here, what I am trying to do is for key value in student item. So what would that even print for me? Can I just print the key and the value? And then see what that would be before I even do anything. Okay, John Decker is the old name. Josh Decker is the new name. Right now, it's not going to do anything. So this for loop prints each key and value. So each time the for loop goes over the dictionary, it'll grab each element with the key value pair. So my code, if I go back to my code, so I'm going to compare is the value in each case equal to John Decker? So if it finds the value John Decker, then it's supposed to change it to Josh Decker, and so on and so forth. So we're going to check if the value is equal to old name, then modify this key. So we're not telling it name because, like I said, we don't know what the key is. So using the for loop, we can determine whichever element's value matches with the user entered value. That's my key. So at that key position, change it to the new name. So as simple as that. Again, we will see for loop in more detail. So if I say John Decker and I change it to Josh for now, now my new dictionary has only Josh instead of John Decker. This was the original dictionary. This is the new dictionary. So one thing to remember is if you do something like this, it is going to be a case sensitive comparison. So if I do John Decker and then make it to Josh, it's not going to find it. It's not going to modify it because it is exactly looking, including the uppercase, lowercase combinations to find that element. So that's about this as far as modifying the elements. And we won't see a lot of this using the value. We usually know what the key is and we'll try to use that key to modify. But in some cases, I might ask you in the exam to change it if you don't see the dictionary, if you don't know what the key is, how would you change the value? All right, so next one is the len function. Our good old len function, we operated it on a list to see how many elements were there in a list. Same story here would be how many elements are there in your dictionary. So just by looking at it, I can tell um, this is element number one, element number two, three, four, five, six. So good rule of thumb here is to look for these colons, these little colons here and say, okay, so if I want to know how many elements are there in student, then I try to print it, it's going to give me 6 elements. I do want you to notice one thing here that here my key is a string, but the value now is a list. Here this is a string, but the value is a tuple. So now we're getting into a little bit more complex data structure, a little bit more adding more complexity to our dictionary to see how can we navigate that. All right, before we get to that, let's see what a note is. Oh, len function will always return an int. So anytime you use the len function, the return data type is going to be an integer. All right, deleting dictionary elements. So we've seen accessing, we've seen modifying. So now what if I want to delete an entire key value pair? So number one is using the del method. So we've seen del in lists when we use lists. So I have this dictionary name and CWID major. So I have 3 elements with 3 keys, name, CWID major. If I want to delete major, I can simply use the del keyword and I can say del student major. So when I do that, the original dictionary had 3 elements. Now my new dictionary doesn't have that. The only problem that we have seen in lists, and that is again persistent here, is what if you're trying to delete an element or a key that doesn't exist. So this dictionary doesn't have a key GPA, and I'm trying to delete that, then Python is not going to like it. It's going to say key error. We can use the same methods we've done before, use exception handling, or we can use the in operator and say, hey, if and only if GPA is in student, then only perform this operation. So we can specify and then get away with it and say, oh, nope, we're not going to raise any exception. We're good here. So that's an if in operator in an if statement. Another method, if we don't want to use the del keyword, what else can we do? We can use a pop method. So we've done this in list also, and we can use pop. And if I print the dictionary now, I'm going to print it before and after. How about that? Okay, so let's see. So before my dictionary, my dictionary had 3 elements, but I'm trying to pop phone, which doesn't exist in my dictionary here. So again, your dictionary can all be in one line, or I like to visually see it better. So I kind of break it down into 3 individual lines. You don't have to if you don't want to, that's up to you. So pop also has the same pesky problem that if the key is not there, pop is going to fail. All right, let's see if there's any other method. Um, So both of them do the same thing. There's no method in dictionary that if you try to remove, let me try discard. I could be wrong here. What if I use the discard method? Okay, so discard is not even in dictionary, so that don't worry about it, I guess. So if you want to use the del or the del statement or student dot pop method. So try and remember the difference. I'm saying del statement here, and I'm saying pop method here because pop is a function that the student object is using. So we will see those differences also more and more. So either of these, if you want to do, you have to make sure you either use exception handling or you use the in operator to find if they're even there for you to delete. So pop will take the key. So on that. So either of these can be accomplished if you can just check if the key exists. So that pretty much and then I want to go over the in operator again. So we've seen that already to see how a key exists in a dictionary or not. So in this dictionary, I can say if name exists, then print key exists. If not, key not found. Okay, so we can simply test this dictionary, and this dictionary only has 3 keys. So if you provide anything other than these three, then it's going to print key not found. So there you go. And if I try for phone, it's going to tell me, nope, key is not found. So instead of these print statements, I would simply put the delete statements here or access or print those values. So if phone isn't even there, how can I print phone? So at that point, it'll simply tell me phone was not found. So that's about all I wanted to show in this lecture. Um, Hello. So today we are going to see complex dictionaries. What do I mean, complex dictionary? Let me share my screen and let me show you what it is. And then while we look at it and I will explain it to you. So this is a student and all the student data, I have saved it in a dictionary. So my dictionary has the first key is age, and then it has a value, which is an integer. Second key is a string, and it's a GPA, and the value is a floating point. Third is another string, and the value is another string, the value John. And the fourth is colors, but the value here is a sequence, which is a list. So dictionaries don't necessarily have to have strings or floats or integers as their values. They can have any kind of sequence. So in this case, this happens to be a list. And in the next one, this happens to be a tuple. The next key also happens to be a list. But the next key is a whole entire dictionary. And in that dictionary, we have a key and a list. Key and a list. So it could be any combination of list inside a list, or a dictionary inside a list inside a list, or a tuple inside a list, and so on and so forth. So right now, I'm going to say this is pretty basic, simple when you understand. If you know a student at a university, we know that they have courses, and those courses can be broken down by fall, winter, spring, or summer. If you're only tracking 1 year, let's just say that. And I'm using a tuple here for their sports. No other reason, just to use multiple kind of data structures. That's all. So here I'm using a list and a list and a dictionary. And if you have a dictionary, a big dictionary like this, how can we manipulate that dictionary? How can we add elements? How can we delete elements? And how does that even work? That's pretty much the scope of this video. So if I have to, let's go ahead and print this student using my Suchi print statement. And then it's going to tell me that each of this colors is a list, and each list element. So if I want to access any element, I have to use two indexes, I have to use colors, and then I have to use the appropriate index. So on and so forth. So actually, instead of trying to explain what it is by looking at it, how about we do some operations on it and then try to understand it better? So for example, if we have a situation where we are supposed to add blue as one of the colors for the student. So let's say that's my first to do. So blue is going to be in the colors. So for now, I'm just going to say student colors is equal to, can I just simply say the index, grab the index colors? So that's how I can access the entire value, right? So if I do that, and if I just print student colors, what is it going to print me? So there you go. I just got the list that I want. Now we know how to operate, how to modify list elements. So how can we add blue to this list? And I'm telling, I guess when I say add one of the colors, so you can either do an insert or you can do an append. If I tell you I want it only at a specified position, then you would do insert. But because I'm simply saying add blue. So to this list, how can I add another element? Dot append was the element, and to that, if I simply do blue, now if I try to print the colors, there you go. So that's only half the job. I have modified that list. Now I have to put it back in the original dictionary. So how can I do that? Well, simply if I do student colors is not the old anymore. So we remember how to modify dictionary elements. We just take that index position and then put our new value here. So what is our new value? So our new value is nothing but the dictionary we just appended color blue to. And there you go. If I now print the entire dictionary, it should have blue at the end of this list. So again, you know me, I would like to do everything in one. So how can I do that? So student colors is nothing but student colors. So there you go. So simply if I, and here I don't even have to do that anymore. I don't even have to do that anymore. So to student colors index, I'm simply appending blue and it will still give me the same result. So again, until you get comfortable, if you want to go about this way, having multiple variables and then go that route. So another example, add a Maymester term with Accounting 101 as a course. Okay, so Maymester would be, so right now I only have 4 terms, fall, winter, spring, and summer. Now I'm supposed to add another term with Accounting 101 as a course. So how can I do that here? So first of all, how about I create a key value pair or, well, let's see. How can I create a key value pair, a brand new key value pair? So if I do that, let's see. So, and for that Maymester, I'm going to add a term, Accounting 101. Let's see. Let's see what is that going to result. So ideally, what I'm looking is under courses, I want another term, and in that, it has to be a list, and the first element has to be Accounting 101, the way my dictionary has been defined. But by doing this, what am I going to do? Well, I'm actually creating a brand new key in this dictionary. Instead of inside the courses, Maymester is its own key. So that is how we have to use another index because I have to route it to, hey, inside colors or inside colors. Now create a key called Maymester and Accounting 101. Okay, let's go ahead and do this and see. Well, Maymester must be integers or slices. Student. Oh, not colors, my bad. Courses. Why I did colors? So for student courses, Maymester, but see, this is not a list. All of these terms are lists, and inside that list I started maintaining a courses. But maymester is not a list, it's a straight up string. Why? Because I'm giving it a string. So how about instead of giving it a string, I give it a list just by wrapping it in square brackets. So now I got what I want. So if I want to add another course to maymester, all I would have to do is append to that element. So now every time you have to parse through a dictionary, go down levels, you would have to use square brackets and that key. So because maymester is at the second level, we had to use two sets of square brackets, courses and maymester. So let's see more to-dos and see drop math 101 in fall. So this student is enrolled. As of now, we can see for fall, he is enrolled in math 101. If I want to delete that, so first, how can we access that list at all? So students, courses, and because we said fall, so let's simply do that. And let's do um, print. All I'm doing is I'm trying to print the courses for fall. When I do that, it's telling me, okay, these are the two courses. Now we know how to remove an element from a list. That would be using the Well, if we know the key, then we use pop. But if we know the value, and here in this case, I'm asking you to delete 101. If I were to ask delete the element at index position 0, then you would be using a pop or you would be using a del statement. But because I'm telling you the value and say delete math 101, then you would simply do, instead of printing this, now that's a list. From this list, remove math 101. As simple as that. So we're directly manipulating this dictionary. So we're not creating any variables and then try to assign those. Instead, we're operating directly. So if I do that and I try to print student here, Math 101 should not be there in the list anymore. So now fall only has one course, which is English 101. So that is how to delete elements. Now, the next to do is add a user entered course for winter. So winter already has some courses. So the user should be able to enter a course now. So it should be another list element. So if I do my job correctly, if I do the to-do correctly, what should happen is here I would have another index position 2 and it will have the user entered value. So let's try to do that. So the user is entering a course for us. So student and then courses will give me access to this entire dictionary. Now, if I see winter, then it will give me access to this entire list. So to this list, if I simply append whatever course the user enters. And right now we're not doing any validation to see if he's entering good values or not. Right now we're just going to simply append. And then if I print the student, it's going to ask me enter a course to add. So let's just say accounting 101. Right? So if I do that, now for winter term, there's a new element and it is accounting 101. So that's how we can add user input values. So all right, to do, ask user for a term and a course and delete that course from that term. So it's very simple, very similar. Instead of adding, we're deleting, but this time we're also asking the user to give us a term. So, hey, you choose. I'm not going to, what term do you want to add a course to? And I will do that for you. So, very simply, dictionary name. The key for courses will be inside square brackets. So, and then instead of fall or winter or spring or summer, this term, whatever the user is going to give us, will be in the second set of square brackets and to this term. So now if the user enters fall, we're accessing this list. To this list, we're supposed to append whatever course he enters. Very similar to what we did earlier, or are we supposed to delete and delete that course? So actually we will be removing, as simple as that, we will remove that course. Right? So for example, if I want to delete Math 101, which we have already done that, let's see if we can delete English 101, English 101 from fall. So let's see, run, and I'm going to say fall, and then English 101. After I do that and I print, it's not going to have English 101 anymore for fall. So my operation seemingly worked good so far. The problem with user input always is user may not give you correct values. You're telling him to give you fall, winter, spring, and summer, but he could be quirky. He could enter fall all in uppercase, or he won't even enter any of these. He'll enter his own value. In that situation, when you try to remove a course from a term that doesn't even exist. So if I say Maymester, and then enter the course to delete, I'm going to say Accounting 101. See, it's going to tell me that, hey, this Maymester is not even in there, and that's true. So we cannot always rely on the user to give us correct values, but we can still make it possible to see if term in student, not just student, term is not a part of the student, courses is part of the student. So first, so we have to drill down to courses. If student courses has this term, so if courses has fall, winter, spring, summer, or whatever term, then only, let's do this. In that case only, how about we say only if that term exists, then we will ask for the course. Otherwise, why even ask for a course, right? So this is all great. So if the term exists, then it will try to ask, okay, what is the course that you want to delete? But what happens if we don't have the term? Can we tell the user, hey, term doesn't exist? Very simply, just user friendly. So here, if I try to enter Maymester, right off the bat, it will tell me that the term doesn't exist and I'm not asked to enter a course again. So yay, that's great. But here, now if I say fall, and give it a course that it doesn't have, Accounting 101. See, Accounting 101 is not even in fall, but I'm trying to delete it. Then Python is again going to say, hey, you want me to remove something that doesn't even exist. So again, what we do is if course in the name of the dictionary is student and the first level is courses. The second level, now we have to see, we can't just look in courses, we have to see in this particular term that the user entered. So if the user enters fall, we have to check in courses in fall, is Accounting 101, is it available or not? So now we're starting to use variables. So earlier we used straight up double quotes fall or double quotes winter, but now we're asking that from the user. So that's a variable, so we cannot put it in double quotes. So if student in courses in that particular term, then only remove the course for that term. Else, so else, this else corresponds to this if. So if course is there, remove it. If it's not there, we can simply say student not enrolled in that course. There you go. Or I can even do my format literal, and instead of doing that course, why can't I tell him that this is the course you entered? So let's see how that works. So I'm going to do fall, and I'm going to say Accounting 101 will tell me student not enrolled in Accounting 101. Where is Accounting 101 coming from? It's coming from this variable that the user just entered. So there you go. This is a very simplistic way to check for keys. again, if the user enters uppercase fall or uppercase course names, it's not going to work. And we will see we can actually convert everything to lower. So whenever we are trying to do any comparison on strings, we can say convert the whole thing to lower, whatever the user enters, and then compare it with everything converted to lower, even in this, and see if that works. Then remove the course. So let's see if the user enters fall, and then I say accounting or say math 101. Let me be nice and say, okay, delete math 101, but see math 101 in the dictionary was all lowercase, but here it is all uppercase. So let's see how that works. Oh, okay, so it doesn't, this is a list. So course lower in student, course term is lower. Oh, oh. If course, my bad. Let's see if course in student. So course dot lower, I cannot do this with a list. I cannot, this whole thing is a list because courses and term gives me a list. So I cannot convert that to lower, but I can always check if whatever the user enters, I'm going to convert that to a lowercase and test if that is present in this list or not. And I can do that. So now if I try to do that and say fall and math 101, it will tell me, okay, it still didn't want to remove it. Why? Because math 101 is not in the list. Okay, remove course dot lower. So again, I have to do the conversion again. But remember when we said that course is not modified here, it's actually creating a copy. So there we go. We do that now. Fall, and this time, please work. So there we go. It deleted math 101 from this. Same thing I can apply here. If the user enters all uppercase fall or any combination of upper and lower case, I can simply do that here. And the beauty is you can also perform the same operation inside square brackets, and Python will let you do that. But again, I don't want you to get overwhelmed. So let's not worry about the case and the validation. We'll just stick to our basics. We're going to assume that the user is going to give us the appropriate case values. Okay, but we're still testing if those keys exist in our dictionary. So there's that. So with this logic, if you ask the user for a term and a course, this time we're supposed to add that course to the term, but we have to check if it exists or not, because remember, all of these are lists. All these courses are stored in a list, and lists will allow duplicate values. So, but we know that in a real life scenario, a student cannot be enrolled in the same course for the same term 2 times. So our goal is to pretty much do the same thing. So I'm going to go delete. And the best way to learn code is always practice. Type it out and practice it out. Okay, so the user is giving us a term, and he's also giving us a course that he wants us to add. So very simplistically, if I can do that, I would go to students courses. So that will take me to this dictionary, this entire dictionary. So whatever term he enters, so if he enters fall, then I'm going to navigate to this list. So to this list, so now I got the list that I need to manipulate. But before anything, I'm going to have to, well, let's add. So append course. If I do it very simplistically, this is what I'm going to do. Student courses term dot append course undefined student is student, not students. So that's the name of my dictionary. The first index is courses, and the next level index is term, which is a variable. It could be fall, winter, spring, or summer. So that would be this, or this, but any one of them will give me a list. So to this list, I'm appending the course. So very simple. Let's start there. So I'm going to assume the user will all give me good values. So if I add accounting 101, we've seen that it worked before for us. It added accounting 101. But the scenario will be if We are giving him a term and we're asking to add Math 101. But see, Math 101 already exists in this list. So technically, it should say that already exists. So, but still, it's adding because we're not doing that kind of checking. So now I'm going to add the check. So I'm going to say if this student for this term courses. So I got this list. So let's just assume user is going to enter false. So I got this list. So how can we check that in this list math is there or not? So very simply, I can do course in, because when I say Math 101, that's the course that the user is entering. So whatever course that is entering in this variable, if that course is in student, the courses and the term that is specified, then we're not supposed to add anything. We'll simply print student already enrolled, else only when the course is not there, then we will append. Okay, so again, I can add a little bit more here and say earlier, like we said, we want to make sure he only enters fall, winter, spring, or summer. So we have to test if term in student where courses, then only do all this, then only ask for the course. If the term is not even there, then don't even bother to ask for a course. Simply say, so to this if, the corresponding else will be here, and we will simply say print term doesn't exist. Okay, that's one level. Also, as soon as he enters the course, we're going to check if course there you go. So we've already done that. If course in student, we are already saying enrolled. If he's not, then we're going to simply append the course. So let's see how that goes. So if I say Maymester, it's a term doesn't exist. That works fine. So I'm going to say, okay, fall. But this time I will say Math 101. It should say student already enrolled. So it should not do anything. Okay. So now if I enter fall, and accounting 101, then only it should add me accounting 101 at the end. How about that? So that's about all the to-dos that I want to do for complex dictionaries. I have some to-dos for you later on. So I hope that makes sense. It can get a little overwhelming, but it's pretty much like a treasure hunt. You just have to follow the trail and see what is the data structure. So if I asked you, can you add a sport to this? Can you add one more sport to the student? You should immediately tell me, Miss Suchi, that is a tuple. You cannot add any elements. I can retrieve the elements for you, but I cannot add any more sports. So how can we retrieve sports? Very simply, name of the dictionary, and then sports is the key that will go in the first level. And that's all for now. That's all I have. So it will give me the entire sports tuple, and based off of this, just by that, if I want to get the second sport for whatever reason, I can say index number 1 is the second sport, and it'll just give me badminton. So there, so practice a little bit, play around, and see what you can figure out here. So that's the end of this lecture.
For looping in dictionary. So this is like the fourth video lecture in this series. So let me share my screen and get started. And you can see. All right, so I can go back to repos and continue the dictionary and sets repo that we've been doing. So you have a table of contents here. I can browse down to looping through dictionary. So that's the next one in this series. So just like we have used a for loop to go over list elements, or a tuple to go over a tuple elements, or we have also used them for strings, we can use a for loop to loop through a dictionary. But before I can tell you how to do it on dictionary, let me do a compare and contrast with what we did in lists versus what we're going to do in dictionary. So remember that in lists, whenever you use the for loop on a list, the loop variable stored the value. So what does that even mean? So let me see. So ignore that for a second. I have used it for something else, but focus on the list. So I have one list, and that list has 4 elements. It has 3 strings and 1 float. And if I use a for loop and I say element in each list, so literally for loop in any case is always bare minimum 4 words for the loop variable name. So the loop variable here is element in, and whatever sequence you're using, it could be a string, then you would put the string there. If it's a file pointer, you put the file pointer there. If it's a list, you put the list name. If it's a tuple, you put the tuple's name. So very similarly, spoiler alert, dictionary also will be something very similar to that for loop variable in whatever the dictionary name. So in this case, when we were trying to print each element, the loop variable was storing the values in each case. So for loop, if Python reads this for statement, it pretty much reads it as long as there are elements in the list, keep doing whatever is in the for loop. So in this for loop, I have 2 statements. One is a print. The other one is a sleep statement. I just wanted to introduce a time delay. I don't want it to execute all at once. I want it to 2 seconds with a 2 seconds delay. So you can actually see what Python is doing. So that's why I had to import the module that will allow me to use sleep. Or remember how we did our imports from time, import sleep would eliminate the need to do this. There it is, it's gone. So if I do this hypothetically before I even execute, what is Python going to do? It's going to go look for the first element. So that when the loop executes, it starts thinking, okay, what's the first element? Grabbed it, printed it. Sleep 2 seconds means wait 2 seconds. And then the loop goes back again to element in list. That means, are there any more elements in the list? And the Python pointer was here earlier. Now the pointer moves here and says, yes, there are more elements. What do you want me to do? All right, go ahead and print that element you just have and wait 2 seconds, and then go back, get the third element, and then wait 2 seconds, and then get the fourth element, print it, wait 2 seconds. That's pretty much how the execution is going to go. And now let us see how it's going to go. If I could see the run button here, I would really appreciate. There you go. So it's printing Mary Kay because that's the first element. And then the second element, 2 seconds. Third element, 2 seconds. Fourth element. So it is looping over the elements, and we have seen that. So that's what I meant when the loop variable, in this case, I used element as the loop variable. I could very simply use I or J or line. For files, we've used line, but here I'm using element. So now let's see in dictionaries, on the other hand, so if I convert this into a dictionary, very simply, instead of having a list, I will say, now it's not a list anymore. I have given a key name and I've given the value Mary Kay and a key CWID and a value. So the values were same as before when we were seeing the list. These are the same 4 values, but now I've given them keys. And then now if I say for element, so the for loop variable is, I'm still again naming it element. And then if I loop it over, what is it going to print? Is it going to print Mary Kay 17845 CNS 4.0? Let's see what it does. And then I will explain what's going on here. So when you execute that, oh, it's not printing the values, it is printing the keys. So that's the note in dictionaries, is when using a loop, for loop on a dictionary, the loop variable will store the key and not the value. So with that information, then if you want to print, have a really big dictionary here. So let's see if I print this whole dictionary, and I'm not doing the time delay anymore. That's a lot of elements. It'll take a lot of time, or not. So I have 1, 2, 3, 4, 5, 6, 7 elements here. So instead of calling it element, I'm going to call what it is, because when you loop over a dictionary, it is always going to get the key. So I'm going to call it key, and then I'll put a colon here. And how do I get the value? We know, given a key, how to get the value. We put the dictionary name, and the key in square brackets will give me the value. So very simply, if I do that, that is how I can use a for loop to print elements. They're all printed at the same time, but in the background, Python is doing it one at a time. The time delay is microseconds, and that's why we don't get to see that happening in real time. So that is how we use for loops, and we are going to use for loops in a little bit more complex dictionaries in our assignments, but that is all for this video. In Dictionaries and Sets chapter. So let me share my screen and get started. Oh, I cannot see what I'm looking for. Give me a second. And if I go to my main.py, all right, so today we are going to see dictionary methods. So in strings, we have seen a bunch of methods. We have seen upper, lower, L strip, R strip. We have seen split. We have seen testing methods like is upper, is lower, is alnom, is digit, so on and so forth with strings. For lists, we have seen some methods. We've seen the append method. We've seen the remove. We have seen the pop method, and so on and so forth. I cannot remember all of them, but I know that we have seen some some methods in lists. So very similarly, there are some dictionary methods that I will not be able to cover every single dictionary method for this class, but I will go over some of them, and some of them might be very similar to you, just like here, the copy method. So anytime we wanted to make a duplicate copy of a list, we used a method called copy. So from now on, I want you to focus on one thing, and that is whenever you use a data type or a data structure, and in this case the data structure is student, which happens to be a dictionary. So whenever you have a data structure and a dot, and then you have a function, and here, how do I know that this is a function? Because it has a name and open close parentheses, and inside that open close parentheses there might be some values, sometimes there may not be any, but this is a function call. So anytime you have a data structure dot a function call, this is now called a method. So not a function anymore, it's a method. So remember that part. So anyway, so I have a dictionary called student. It has 4 elements, and that's the key, that's the value, key value pairs. So 4 key value pairs. And then if I want to create another student with the same values for whatever reason, then I would create it using the original dictionary, which is this, dot a copy method. And copy method doesn't take any parameters, at least not in this case. So, and then that will create a new student. So when I try to print a new student here, it will pretty much print all the values that were there in the student dictionary. So we've seen copy method before. And next is clear. So if I use the clear method, and let's try to see and do that. So clear deletes all the elements. And let's see, does in the earlier case, copy method returned a new dictionary to us. That's why we were able to save it in a variable, and we were able to print it in using the print statement. But what is the return type of clear? Is it going to do anything, or is it going to do none? So basically, clear is a void method, so it's not going to return anything. So we can simply use it like that, and then instead of printing new student, I'm going to print, okay, now print with the original dictionary. I tried to clear the dictionary contents, and now I'm printing to see did it even clear it. So it won't be none type anymore, it will be the dictionary. So remember what methods are value returning and what are void. So the next method is get, and we've already seen get, that when you have the index and you want to get the value using that index, but you don't want to raise an exception. So get, the beauty of get is you don't have to do exception handling. You don't have to do any kind of if key in the dictionary. You can simply use get, and if it doesn't have that, then it will just give a none type. So it's sometimes it's a value returning if it finds the value. If it doesn't find the value, it returns nothing. So let's see both scenarios. So in this case, I'm using on the dictionary dot get, and I'm providing the key value. So get in this case is a method that accepts one argument, which is a string, and that is the name of the key. And then here, if I say now print me the value of that key, so that's great. It's going to print it because name is already there in the dictionary. So now I'm going to add an input statement. So I'm going to say, hey, user, you tell me what key you want and give the power to the user. So if he enters the key, we're going to retrieve the value and we're going to print it for him. How simple is that? So instead of the string, now it will be the variable key. So whatever the user gives, it's going to be a string, and that's going to get passed to get, and get is going to retrieve whatever the dictionary has if the value is so. Let's see if I say, okay, instead of name, I'll say CWID. It found the CWID and it returned the value of that CWID. Now I run it again and give it a key that it doesn't have. So if I say phone, it's going to return a none. So if you just use the print statement, it's simply going to print none because it's not returning anything. So we're going to test for the return type and say, so it's going to do none. So how can I tell the same thing to the user nicely? Okay, so if instead of name, I'm now going to call it value. So if the value or the type, because that's what is getting returned, is none, right? So value has the type none. So if the type of the value is none, that means we did not find the key. So we can nicely say, instead of just quitting on him, we can say key not found. Okay, even though it's not raising an exception, we still want to be user friendly and say, we did not find what you wanted us to look for, but if we did, we happen to find a value, then we're going to simply print the value. So the value is the one that stores the value of this key element, and then I'm going to test the type of the value. Okay, so let's see how instead of none, now if we enter the key, it's going to have to tell the user, hey, type value. Sorry, if value is none, and then I'm going to do phone. It'll tell the user key not found. So that is very simple. What else can we do here? So that's get method. So let's look at update. Oh my god, update is a very versatile method. It takes a lot of different types of data values, and it gives you different types of results. So let's see. We've already seen when we were creating the dictionary that update was taking some values. Let me see why it's breaking here. Something is not right here. Maybe it's just simply the space. All right. For whatever reason, it's not liking this. Execute and see. It says email and it has a, oh, that's a tuple. That's a tuple. So tuple. So this is a tuple and this is a tuple. And inside the tuples, you cannot have a colon. You have to have a comma. So there you go. I'm sorry about that. Fix your tutorials based on that. So now, new dictionary is equal to, so I need the student dictionary apparently from here. Grab the student dictionary. There you go. I'm going to delete that. So I have a student. I like to space it all in different lines so I can see very clearly what's going on here. So that's a student. And then I'm creating another dictionary. And in that dictionary, I have some extra values for this student. So it has GPA value and it has email as rhodayulin.edu. So now if I use this update method on this new on using this new dictionary as an argument, I'm going to update my original dictionary. What is it going to do? Is it going to freak out because GPA is already here and now I'm trying to use an update? What is going to happen? So let's see. So it updated my previous value for GPA from 4.5, which it's not true, it can be 4.5 to 4.0. And not only that, it added a new element. So update is versatile, that if the key doesn't exist, it will add it to the dictionary. If the key already exists, then it's going to overwrite the value. So that's one way to use the update when you're using a dictionary. You can also use a list of tuples. We have seen that in the very first or the second video, where we could pass, instead of passing a dictionary, I can pass a list of tuples. The first tuple will have the first element in a key value pair, where it is GPA, comma 4.0, and then it's email, comma email address. And then when I try to print it, it's exactly going to print the same thing here. So update accepts both a dictionary and a list of tuples, provided the tuple should be exactly 2 values long. You can have as many tuples as you want, but each tuple will have only 2 elements. So that was update. Items is something I really like a lot. It'll just print me the items of the student. Again, I keep deleting the student dictionary. So if I just want to know what are the items, so when I say items, it'll print both the key and the value in a list, inside a list of tuples. So we've just seen the list of tuples. So the first tuple has the first element, the second tuple has the second element, and all of these are inside a list. So instead, if I just want to know, or I can use a simple print statement and say for a key in student items. So this items has everything. So key will just print me the key. So if I use key, then it is simply going to print me just the keys, the tuples in each case. Okay, so if I use, instead of items, if I simply do keys, what is that going to give me? It is just going to print the keys of that dictionary. No, I don't want the keys, I just want the values. Then we can do this. So it is going to print just the values in that dictionary. So you can use, based on what our requirement is, we can use our for loop with the entire student dictionary, which we've seen that in the previous video. We can use a key on the student dictionary, or we can say, no, I don't want the keys. Who wants the keys anyway? I just want the values. And instead of key, I'll rename it better. Key couldn't hurt, but it'll be more descriptive. If you use value, and for each value, it will print me the values. No, I just want the keys. Then we can use what we had. If we don't specify anything, by default, it'll print the keys. So that is items, values, and keys. So these 3 methods will help us accomplish, depending on our requirement. We have to use what we need. All right, so pop method returns. So this is a value returning method. So it returns the associated specified key and removes the key value pair. So pop is doing 2 things. It's removing name from the dictionary, but it is also returning the value of that name. So this is a value returning function, a method. So let me do that. So when I try to print, it's trying to print student. That's good, but I can also print popped. So pop will also store Suchi. So it's a user-friendly thing, right? When you try to delete a book, and then after the deletion, you can say, so this book was deleted, and also give which book it was. So you can use that in a print statement. So that's one. And pop item is very similar. And to me, let me see. Pop item will pop the last element of the dictionary. And when I say last, again, we've talked about it and we've said dictionaries really don't have any order. They're unordered data structure. So in an unordered data structure, what is the last element? Well, in this case, the last element is the last element that was updated, I guess, and then it will remove that last item. So pop item, unlike pop, you had to tell it which key to delete. Pop item doesn't require anything. It is going to delete the last element and it will return that last item. So whatever you do the deletion on, you can print it. Here you go. So I don't know what it's going to delete. So what did it delete? And also do Fuji print here. Okay, so in this case, what did it delete? It deleted pop item. It deleted GPA and it deleted the value for the GPA. So that's what it gave me a list back. So the key value pair was returned of what it deleted. So GPA, because maybe it's last. So if I try to run it again, will it again delete GPA? Yes. And what about if I move it back here? And I run it, this time it is deleting the major. So it's returning me the key value pair here, and that's a tuple. So that's about all the dictionary elements I wanted to cover today. Section is serializing dictionaries. What is serializing? Serializing is the process of converting an object. An object could be a dictionary, an object could also be a list or a tuple, convert it into a string and be able to write it to a file. And this particular file is not going to be your regular good old text file that you can go and read it in a human readable format. It will be a binary file. That means the data will not be readable by the human unless you use the appropriate application. So for example, a Word document, it is a Word file, but unless you have a Word application on your computer, you cannot open a doc file, but it still has the data in that appropriate format. So very similarly, we are going to serialize dictionaries, and when you serialize a dictionary, it will retain the data types for all the data values, for all the key value elements. Not only will it retain the keys data type and the values data type, and every element in that value also is retained, and when we can read it all back. So when we did our lists, we had to literally convert everything into a string so we can write it back to a text file. We do not have that hassle. We do not have to convert it into a string to be able to write it, because this is not a text file anymore. So this is a binary file. So remember back when we were doing files chapter, we talked about two types of files. One is a text file, another is a binary file. And the binary file could be a music file, a video file, or a doc file, or anything that you cannot use a text editor to open and read in. That'll make sense. So without further ado, and in Python, this kind of serialization is called pickling. So serialization is there in Java too, and in Java it's a straight up serialization, but here we call it pickling. So to be able to pickle a dictionary, we need a module to called pickle to use, simple enough to remember. We're pickling, we need pickle. So there you go. If this is my dictionary with the key value pairs, name, age, GPA, courses, sports, and so on and so forth. And then I have this module called pickle. What is the syntax? It's very similar to, let me change the dictionary name from student one to just student here. So it won't, the error will go away. So remember the with the context manager that we had used when we were doing our files? It's very similar. And with open, and this would be the name of the file. I named it .txt just because I could rename it to anything. So I'm going to change it to bin because this is a binary file. So I don't want to get confused that it's a text file and I can open it in a text editor. I can't. So I'm going to rename it to student.bin. And then the mode, when we were writing to a file early on, we just used the mode as W. But here, because it's a binary format, we're going to add a B. So WB is the mode. And then the syntax the same is as file pointer. Now, using this pickle module, so there's a function inside pickle module called dump. I'm going to call that dump function with two arguments. The first argument will always be the dictionary, and the second argument is going to be the file pointer. So what am I pickling? Where am I pickling it to? That's the order in which dump takes it. So very simple, two statements, and you can write your entire dictionary into a file. So if I do that and I run the code here, it will create a file called student.bin. So let me go ahead, open that file. Of course, I said you can't open it, but what I meant is it's not really human readable. You can open it and you can see some characters, but most of these characters are encoded. So that is how pickling a dictionary is going to look like. Now, when we have a dictionary like this, when we have a file like this, how can we read it back into a dictionary? So that is the process of unpickling a dictionary. So let's see how we can unpickle a dictionary using the next. So here there's a note for you that when you open a file that doesn't exist in WB mode, Python automatically creates it. It did that when we were using a write mode. So anytime you use any variation of a write mode, if that file doesn't exist, Python will create it for us. So the next order of business is, okay, now how can I read student.bin into the dictionary? So that is very simply, I'm going to keep the module. I'll still need the module. So I'll need the import pickle module. And now the context manager will look like open. Student name is not text anymore. I have renamed it to bin. And then I'm going to read it in RB mode. So it's not R anymore, it's RB. And as FP, now the syntax is different. Now I'm storing it in a dictionary named student equal to pickle. To load, I'm passing the file. So I'm asking, hey, load function, take this file pointer as an argument and return me a dictionary, and then I can store it in this dictionary. And that's if I try to print it from there. So hypothetically, let's just for a second change it to txt. So I don't have a txt in my file. So when I try to open it in RB mode, Python is not going to like it. So that's very similar to when we were doing files. Anything you want to read should exist. Anything you want to write to can be created for you if it doesn't exist. So I'm going to change this back to bin. And can we print our original dictionary? There you go. Every single data type is retained, every float, string. So not everything doesn't have to be string anymore. So that's the beauty of serialization, is you can preserve the formatting of your data type, including all of its data types. So that's about all I wanted to do in this lecture. Maybe I will give you a try this later on for you to try doing pickling with another dictionary. So that is it. Hello. So this is the video for chapter 9, Dictionaries and Sets. Today we're going to cover sets. So before anything, let me just get started by sharing my screen. And here we go. So in the table of contents, you can browse to sets and then go from there. So I'm gonna go to sets here. All right, so sets, what are sets? So we are navigating into the fourth sequence in Python. So we have seen lists, we have seen tuples, we have seen dictionaries, and this is the fourth, and good news, the last built-in sequence that Python has that we need to take a look at. So sets are objects that store a collection of data. So that's why it is a sequence. And sets in Python are very similar to the ones that we've seen in our in our algebra, where we said set A union B, A intersection B. I hope you remember that, but if you don't, you might want to brush up on your sets just a little bit. So the elements of sets can be of any data type, just like in dictionaries. The data types can be anything. It could be int, string, float, boolean, or list, or tuples, or a set in itself. So what are the characteristics of a set? So order, sets are unordered. So that's good. Dictionaries were also unordered. So lists and tuples were ordered, and dictionaries and sets are unordered. What does unordered even mean? Well, it's like it really doesn't care if the elements are placed in any particular order. Two sets having the same elements in any different order, according to Python, are the same sets. Mutability. So sets are mutable. So there we go. Other than tuples, as a sequence that we've seen, every other data structure, lists and dictionaries and sets are also mutable. That means you can add, delete, and modify elements of a set. Duplicity. So sets do not have duplicate values. So unlike the other three data structures we have seen, lists allows you to store duplicate values. Tuples also allows you to store duplicate values. Dictionaries, the keys cannot be duplicated, but the values can be duplicate. But sets will not allow you to have duplicate values in them. So these are the differences between all the data structures we have seen. So how do we create an empty set? Very simply using the set method. So for dictionary, we use the DICT method. For the lists, we used LIST, and alternately, we also used square brackets. For dictionaries, we used curly braces. Sets is the only sequence that you don't have any parentheses or curly braces or anything. You must use the constructor set. So that's it. So if I try to print it right now, it's going to print just set. That's it, because it's an empty set. So remember how we had two different ways of defining in lists and tuples, but set only has one way to define. So how do we create a set with values? So if we have curly braces, just very similar to dictionary, but it doesn't have key value pairs, but just elements like a list. So pretty much it looks very similar to a list, except for now the square brackets are curly braces. Just that one simple difference converts a list into a set. So now if I try to print these elements, it's going to print me set blue, red, yellow. Because it doesn't have any order and it doesn't have a key, it's not printing me 0, 1, 2, 3, or it's not printing me any keys. It's simply printing me the values. So before I go any further, as a programmer, when you're given a task, you have to understand when should you use a list, when should you use a tuple, or when should you use a set. So for example, if I'm asked to store, say, the data of all the presidents of the United States, present and past, then I could store, and the user requirement is, hey, I should also be able to retrieve. If I say who's the 16th president, the data structure should be able to pull from the list, from the data structure. So what kind of data structure would allow an ordered list of elements, right? We only have two of them, lists and tuples. So for example, I use a tuple because tuple is a collection of data. It is ordered, so I can pick any particular order, and also tuple will allow me multiple values. So sometimes we have a president serving 2 terms, so we will be repeating that. So tuples will allow me to store that data. So is tuple a best data structure? It could be, but what are you going to do if there's a new president? In the next election, there's going to be a new president. How are you going to add that new president? Remember, tuples are immutable, so you cannot modify it. So the decision comes down to, okay, everything else the same. If I need mutability, I can simply store in a list. For example, if I said I want to store the collection, the sales data, just the sales data of my store for each day of last month. Say last month was September. So I will have 30 values in there, 30 floating point values, and I want to be able to retrieve the third day data, and I should be able to retrieve it. What are you going to use at that point? That would be a tuple, because September is already over. You're not going to be adding any more data to it. That data is a fixed data. No more changes are going to be made to it. So tuple is a good choice for that. So another scenario, if you were asked to store all the lakes in the United States of America, what is the data structure that you're going to use at that point? Well, that personally, I would use sets for that, because there's no such thing as first lake or second lake or third lake. They're just lakes. Are they in US or not? So that is when we would use sets. I can still add it. For example, for whatever reason, a new natural lake has formed, I can definitely add that lake, but it doesn't have to be in any specific order. So dictionary is a little bit more complex data structure. It needs keys and data. So if you have keys and values, then you would use dictionaries. If you master dictionaries as a programmer, you can work with a lot of key value pair data, and that's pretty much a JSON string is a key value pair, and XML data, that's also a key value pair data. And if you go into databases like MongoDB, and they are document-based databases, they also operate on the concept of key value pair. So data structure dictionaries in Python will give you that knowledge to manipulate multiple other data structures in other programming languages as well. So all right, so enough about that. Let's just get back to our sets. So we've seen how to create a set with values. So how do we convert another sequence into a set? So for example, I have a list and I want to convert it into a set. I use a method, not a method actually, this is a function because I'm not using anything dot set. I'm simply saying set. So set is a function. So if I have a list called my list and I pass that as an argument to a function called set, it will create me something called my set. So if I print it, it's going to print me all the elements of the set. Well, how will Suchi print the list? Let's see that. So my list. So before we convert it into a set, this is how it looked like. It had some nice indexes, 0, 1, 2, and 3. But now we started off with 4 elements in a list. We only have 3 because set will not allow duplicate values. So even though I had 25 2 times in a list and list allowed me to have that, but set didn't allow me to have that. So each time I print the set, it will print in a different order. So let's see if that is happening in this version of REPL or not. Sometimes every time you run it, those elements appear in a different order. So for some reason it's not happening, so that's okay. So instead of a list, what if I had a tuple? So same method, not the method, same methodology, and that's a function set. You pass a tuple as an argument to a set, and it will convert all the elements. Again, it will convert, it will take off these repeating elements and convert it into a set. And what if I had a dictionary instead? So let's say I have a dictionary with key value pairs, same values as before, but now I have attributed keys, and I think I have added an extra key. It doesn't really matter. So 1 is 25, 2 is 30, 3 is 25, 4 is 40. Same values as before. But now if I convert it into a dictionary and try to print the set, what is it going to do? But in my set, it's definitely not going to be a 25, 30, 25, 40. It's actually doing the keys. So these keys are the ones that are going to form the set, not the values. So that is one important thing to remember. And the last iterative data structure we've seen is a string. So you can do that with a string also. So if you take a string and store it in a variable and then pass it as an argument to the function set, it is going to convert it into a set. When you print the set, it is going to print, drum roll, hello, and there you go. So you have used hello in this order, but when you try to print the set, the order is, it doesn't matter. It printed L first, H and E, O, and what happened to the other L? Because it's a duplicate value set, kind of stripped it off. So there we go. So that is how different ways of creating a set with values, or if you had other data structures, you could convert them into a set, all using one function called set. So how can we calculate the number of elements in a set? Very simply using the len. So we have used len so many times. So len is pretty much has been our de facto for calculating length of all our data structures. So if I try to print length, it is going to print all my elements. Again, that is just me. If you want to do it all in one, that would be fantastic. But if you want to break it down so it makes sense, that's good too. So that's the length. So now we have to modify. So we said sets are mutable, right? So we should be able to modify. So what is modification? So we've seen creation, and we have to see how. We have seen we're supposed to see how to update set elements. Updating would be adding new elements and deleting existing elements, right? So how do we add a new element to a set? By using a function or a method. Here, add is a method because I'm operating it on the data structure. So the data structure dot add is a method. Add is a method here. And to that method, I'm passing an argument called purple. So one argument and one argument only, I can pass it, and it's going to add that. Well, does it have to be a string? Not necessarily. We've seen in the very beginning that sets can have any data type. So you can add a floating point, you can add an integer, and you can add a boolean. It really doesn't matter. So, but it has to be only one element. You cannot add more than that. But what if, Mr. Chi, what if I wanted to add more elements? So add doesn't take a sequence as an argument. It only takes a string, integer, float, or boolean. So now comes the question, what if I had more elements that I want to add all at one time? So what method would I use? That's when we use our good old update method. We have seen update method in dictionaries as well. So I'm going to start deleting all of these and then we can come back to them one at a time. Okay, so let's assume we have a different set. Okay, so this is my original set and then I have a new set. So how do I know this is a set? Well, simply it has curly braces and it has no keys, so that's a set. How do I add these elements to my original list? I take the original list, put a dot and use the update method, and to that update I'll pass an argument, the new set. So if I run it and if I print my original set, now it's got more elements. It should have 5 elements. So the same logic applies here. If I try to have red again here, it's simply still going to have 5 elements because sets do not allow duplicate values. So that is if you had a set. So what if you had a tuple? Set. Just wait 1 second. So what if you had a list? So if you had a list and you wanted to add these list elements to the set, then how would you do it? Very simply, you would use the update. The method is the same no matter what the data structure is, but you got to be careful what is being added to the set. So if I try to print my set, it is going to add blue, red, yellow, 25, 35, pink. May not be in the same order. So there you go. The order is all messed up because sets are unordered. Next one is adding tuple elements. So how would we add elements of a tuple? If I didn't have a list, how would I add elements of a tuple? Same story. 25, 30, same method, no matter what the data structure. So that's the beauty of update. Update is my favorite method by far. So dictionary. So that's this is where it's going to be slightly different compared to lists and tuples and strings, is if you take a dictionary, it will add the keys and not the values. We have seen that when we were doing using the set function. When we were trying to create a set, we were seeing that it was adding the keys and not the values. So the same story applies to this list. It has added 1, 2, 3, and 4, and in this case I also have a 5. So it did 1, 2, 3, 4, 5, yellow, blue, red. If I run it again, I don't know, will it print in a different order? It's not. So anyway, so that is dictionary. The last iterative data structure is a string. So I simply pass this string to the update method and it is going to add all those characters. So that is how to add more elements, 2 different ways. If you had only 1 element, you would use the add method. And if you had multiple, like a sequence, then you would use the update method. So last thing, so I want you to remember, when passing a dictionary to update on a set, the keys of the dictionary will be added to the set. So we've seen that. Note, add or update will ignore duplicate values and only add the unique values to the set. So we have also seen that. So next comes, okay, we've seen how to add values. Now, how do we remove values from a set? The first method we're going to see is remove. Very simply, we've seen remove in lists also, and we've seen remove in dictionary also. I don't think we've seen remove in dictionaries, but we've definitely seen remove in a list. So for example, I had a list like this, and instead of removing green, let me show remove a blue. Okay, so that exists in my set. So if I have a set, blue, red, yellow, and I simply say my set dot remove. That means remove is a method that I'm operating on this set, and I remove blue. It's simply going to remove the blue and print the rest of the elements. The problem with remove is if I try to remove a color called green, which doesn't exist in the set, well, remove is going to raise an error or an exception. So that's not the best way to remove an element. So that's why we have another method called discard. So discard does the same job as remove, except for it is not so finicky. It's just going to just silently fail. So if I run this code, I will see that even though green is not in my set, discard didn't raise an exception. It just silently didn't do anything. So that's two methods to remember, to delete an element from a set, and to remember, use discard instead of remove. So if I ask you in the exam, what is the method that deletes an element from a set without raising an exception, I would expect you to remember that it is discard. So there we go. So we're done with all the modification methods. Here is one refresher for you guys. So if I define a data structure, let's say data structure is equal to list. So let's say I have defined an empty list. What all are the methods available for this data structure? If you put a dot and wait for a second, REPL will tell you that append, we know that append adds an element at the end. Clears all the contents in a list. Copy creates a copy of the list. Count will tell you, well, I'm not going to go over every single one of these, but you can scroll down to see these are all the methods. So the ones that start with underscore, we can't use them like that. We have to use a plus symbol to add. But sort, reverse, remove, pop, insert, index, extend, count, copy, clear, append are all available for a list. But what if instead of a list, I had a tuple? So if I put a dot and wait a second, REPL will tell me tuple only has two. It has count and index. What about len? Remember, len is a function. It's not a method. So that's why it didn't show up here. So we can count and we can use the index method on a tuple. That's pretty much it. What about a dictionary? So if I created an object of a dictionary class, what are all the methods available to do on a dictionary? So we've seen clear, copy, we've not seen from keys, but we have seen get, items, keys. We have seen pop, we've seen pop item. We haven't seen set default, but we have seen update and values. There you go. We've pretty much covered so many methods in dictionary. What about a set? So if you say my data structure is a set now, then you can put a dot and REPL will tell you these are all the methods available. So discard, there you go. We've seen discard, and then we will see the others in just 1 second. So isn't that pretty cool that REPL will tell you what's available? So if you're trying to delete an element from a list, you can just ask REPL to help you out there and we'll tell you all that you can do. All right, so the next order of business is looping through a set. So just like any other data structure we have seen, we can use a for loop to loop over the element of a set. So what is going to be my loop variable? I'm just going to call it set element. Why not? Set element. So that's my loop variable in my underscore set. Let me probably have to grab my set here. So what is my set here? Oh, I already wrote it. So might as well use it. So here my loop variable is val, and I'm going over this set called colors. And if I try to print val, and again, if I introduce a sleep, and this time I'm going to use it for 3 seconds from time import sleep. If I do that, and if I try to run it, it's going to start printing in the same order or maybe in a different order, but it is going to print each element. So the for loop goes over each element of the set, grabs it, and does whatever you want to do with it. Right now, we're just asking it to print. Instead of print, what if I did, instead of print val, what if I said print hello? So what's that going to print? So for as many elements in this set, it is going to print hello that many times. So it'll be hello, hello, hello. So it'll tell us any number of, depends on the number of elements in the set, all these statements get executed that many number of times. So that is looping through a set. Now we'll see some set methods. So I'm not going to go over things that we've already done before, but you're welcome to try these. So if I have a set called colors, and if I want to create a copy of that set, then I would use a method called copy on colors and store it, because it's a value returning method. So copy is a value returning method that doesn't take any arguments, and that's why the parentheses are empty, but it is returning a set back. So when I try to print that set, it will print the same elements. Clear will clear or remove all the elements of the set. It'll still keep the set intact. It'll just clear out all the elements, almost like an empty set. So one thing to remember, oh, we haven't even seen pop yet. Okay, pop. We've seen pop in dictionary. So it removes the first element and returns the first element. So not only is it removing, so in dictionary we saw pop item was the one that removed the last element, and it also returned the last element. So what is going to happen if I try to? So it is returning something. So I don't know what it is going to return. So return pop. So if I use pop here, pop is not taking any argument. So remember, in dictionary, pop was taking one argument, which was a key, and then it was removing the value corresponding to that key. But here we're not sending anything. And then if we try to print the return pop, what is it going to print? And also I can print the set with that element popped. So let's see what that's going to be. So it popped blue, which is the first, while creating the set, I believe. And then it also returned what it popped. And if I print my original set, it doesn't have blue anymore. It prints me red and yellow. So that is pop, no pop item. That's great. All right. So pop item is similar. Pop in a set is similar to pop item in dictionary. Okay, now comes the most important and the most unique operations that we have not seen on any data structures is set operations. So we have said that sets are similar to mathematical sets. So we should be able to do a set union or a set intersection. So what was set union if we try to go back and see? So if you had, say, a team of players, a basketball team and a baseball team. And if you want to see who are all the players in both the teams, then you would do a set union. If you want to see who are all the players that are in the basketball team and in the baseball team, so that and is an intersection operator. So that's what sets allow us to do. No other data structure will allow you to give that kind of information but set. So I'm going to use colors here, and then maybe we can do another example or homework with a better real life example. So I have a set 1 and it has colors blue, red, and yellow. I have another set that has colors purple, red, and green. So a union of these two sets can be calculated in two different ways. One, you can use a method. So union will always return another set. So let me write that down as a note for you. But I'm going to say union set or big set. I don't know. I'm not very creative today. And then if I print big underscore set, instead I will do future underscore print also while I'm at it. And then for now, I'm just gonna cut it. So there you go. So if I use set 1 union set 2 can be literally performed as set 1 dot union method. To this union method, I'm going to pass set 2 as an argument, and then the returned set is going to be stored in big set, and I'm going to print that. But as you can see, there are some repeating elements here. So technically, if you did a union, you would have 6 elements, but guess what? Red is a repeating element, so sets cannot have duplicate values. So they will simply say green, purple, yellow, blue, and red. So similarly, in a basketball team, you have John and Jerry, and in the baseball team, you have Tim and Jerry. And if you ask who are in both the teams, you're not going to say 4 names. You're only going to say Jerry's name only one time, even though he's in the 2 sets. So sets operate very similar to that. So intersection is what are all the common elements in both the sets. So, I got to go back and do the operators. So that's one method, is to use the method union, but another method is to use an operator. So the pipe symbol, which is right on top of the enter symbol. So if you do shift and press the key on top of your enter key on your keyboard, that's a pipe. So if you try to do set 1 and set 2's union, you should use a pipe symbol. So set 1 union set 2, and if you try to print it, it's going to give you the same result. So I'm using print here, so that's why it's looks different. If I use Suchi print, it's going to be really pretty. So there you go. So that is union operation on a set. How about intersection? Intersection will give you the common elements in both the sets. So 2 different ways of doing intersection. I'm just going to show you one, and I want you to play with the other one. So set 1 dot intersection method, pass the second set as an argument to that, and I'm printing it. So instead of just printing it, I'm going to use Suchi print, and then I will print it, and there you go. The common elements in these both sets is just red, so it's going to print red for us. The next one is set difference. Set difference is A minus B. If you remember your math algebra, set A and set B, and if you try to calculate the difference between those two sets, it is going to give you the set difference. So what is a set difference? Very simply, I'm going to cut the extra stuff out, and I'm going to print Suchi underscore print DIFF1. So what is DIFF1? So if I look at these two sets carefully, what I'm asking Python is, tell me from set 1, tell me what are, after removing the common elements, what are left in the set 1. So what is the common element here is red. So set 1 minus set 2, or set 1 difference set 2 will give me all the elements in set 1 minus the common elements. So in this case, if I run the code, it's going to tell me blue and yellow. But is set 1 the same as set 2, set difference the same as set 2? But if I do it like this, what I'm asking Python to tell me is, from the set 2, tell me what are all the elements other than the common elements in both the sets. So when I do that, it's going to print me purple and green because this order is different from that order. So very similarly, how can we use set difference using an operator? So if this makes more sense to you, use the operator, but I would want you to learn both ways. It's very simply set 1 minus set 2, or set 2 minus set 1. So these are going to yield two different results. So that is set difference. And the last operation we're going to do is set difference. So what is set symmetric difference? So we've seen set difference. Now we're going to see set symmetric difference. So what is the difference? Set symmetric difference returns a set that contains the elements that are not shared by both the sets. So what does that even mean? So if I have something like this, I'm going to delete everything else. I'm just going to show you. So set 1, set 2, same colors. Instead of difference, earlier we had difference. Now I'm using symmetric underscore difference as the method, and have set 1 dot symmetric difference. I'm passing set 2 as an argument. What it's going to do is it's going to combine all the elements of both these lists, and then it will take out the common elements and then print, other than the common elements, what are all available in both the sets. So basically it's going to print me blue, yellow, purple, and green. So that's because I'm using print. I'm going to use Suchi print. There you go, yellow, purple, blue, and green in the same order. And can set 2 symmetric difference be the same as set 1? Yes, definitely, because it's the same elements. So that's the set symmetric difference. If you want to use an operator instead, you would be using this. So that's using the method. And then you would be using an uptick to get the set operator. So if I print set 1 tick set 2, or set 2 underscore uptick set 1, the result is going to be the same. It looks the same set. Okay, so the last two things is finding subset and superset. So what is a subset? If you have a bigger set of elements and there's a smaller set that shares every single element in a smaller set is coming from the big set, then you can say that this small set is a subset of the big set. So let's say, for example, for ease, I'm going to say these are the courses offered by ULM. Of course, ULM offers way more than that, but for typing sake, I'm just going to say there are 5 courses that ULM is offering, and the student is enrolled in 2 of them. So if I try to do the subset, so if I see, are the student courses a subset of courses offered, then it's going to return a true or a false, because the student has enrolled in Accounting 101. Is that a part of courses offered by ULM? Yes. Accounting 501, is that offered by ULM? Yes, it is. That's why it's true. So for example, if I do 601, Accounting 101, 2, 1, 3, 1, 4, So only these are the courses offered by ULM, and the student is taking 601, which is not part of the bigger set. That's when the subset is going to result in false. So conversely, we have another method called superset. So superset is trying to ask, hey, is this smaller set, is this bigger set a superset of the smaller set? So here, counting 101 to 1, these are the courses offered by ULM. And if I say is courses offered a superset, but here, because 601 is taken by the student, which is not a part, then courses offered is no longer a superset. So it's going to return false. The only way it will be a superset that every course that the student has taken is only coming from the courses offered set. Then that test is going to yield true. So this is pretty much all about sets that I wanted to share today. This is the last video for chapter 9, Dictionaries and Sets. Today we are going to see comprehension. So we're going to see set comprehension, we're going to see list comprehension. So dictionary comprehension. So we've already seen list comprehensions, and list comprehension is no different. We're just trying to make our code a little bit concise. That's it. It doesn't accomplish anything different. It's not a different code logic. So without further ado, let's start with set comprehension first. So if I have a set with 4 courses, and I am supposed to get only the CINS courses and store them in a brand new set. So without comprehension, how can I do that? So first I would create an empty set, and I'll say, this is my empty set. Of course, remember, set, you can only use the set method. You cannot use this open close curly braces because that will be a dictionary. So I'm going to start a for loop, and I'm going to say for each element or element in my set. Now, all I'm supposed to do is add it to CINS underscore courses dot add, using the add method because I'm adding one element at a time. So for loop will grab each element at a time, and I'm just going to simply add it to the CINS courses. But again, that is not the objective. What this would do is add every single course in the courses set to this CINS courses. So let me print that out and we'll see. So right now it's added all the 4 courses, but that is not my goal. My goal is to see if it starts with CINS, then it's a CINS course. So in my code example in the tutorial, I am using an if, and each course, or in this case, it is each element. So I'm slicing the element string. So each element will have that string. It's going to grab this string and it's going to slice it, the first 4 characters, and then it's going to compare it with CINS. And if it is yes, then it is going to add. If it's not, then it's just going to simply not add it. That's all. So if now I try to print it, it's going to show me only the CINS courses. Another way to do it, instead of slicing, I can simply say dot starts with. So when you come to strings, there's a lot of different ways in which you can accomplish things. And this is another way. If you're saying, hey, does it start with CINS, then it's a CINS course. So either ways that you choose, that's okay with me. But using set comprehension, how can I rearrange the same code to do it all in one line? So remember how we did list comprehension, the new list, or in this case, the new set will always go on the left side. And then we're going to open close curly braces. For list, we open close square brackets, but sets, we're going to use curly braces. So we're going to grab the for loop without the colon, so don't get the colon. And on the left side of the for loop will be whatever goes in the add. In the list, we did whatever went in the append, we put it on the left side of the for loop. Here, whatever goes inside the add will go the left side, and then to the right side, if there's an if statement, that goes in here. And that's it. With all these 4 lines of code, in now one single line of code will give us exactly the same result. So that is set comprehension. Now I can start off with a set And if the user says, I want a list of CINS courses, then all I would have to do is just change out the curly braces and make square brackets, and then it's not going to be set anymore, it's going to be a list. So just these brackets are the difference. The whole logic is still the exact same of how we've done it. So all right, so now dictionary comprehension is going to be slightly different because this is a list or a set, we only had to give the key or the value. But for a dictionary, we have to give a key value pair. So here on the left side of the for loop, you will always have two values. So we're going to see how to do that using a dictionary. So I'm going to clear out the sets, and then let's start with dictionary. I have a few examples for dictionaries here, so let's get started. So we have a dictionary like this. Very simply, I'm using a very simple example. Key is 0, value is also 0. Key is 1, value 1. And then key is 2, value is 4, key 3, 9. So basically, if I look at it, the value is the square of the key. So 16 is the square of 4. So that if I have a dictionary like that, and then I'm asked to create this dictionary. So instead of defining it like this, I'm asked to define a dictionary using list comprehension. So without comprehension, how would we do it? So we would use a range function for this because we want to create 4 keys starting from 0, 1, 2, 3, 4. So instead of 20, I would have range 4. And then I would say, what is this code? Okay, I'm going to take off the if, and I'm going to say, so there you go. So I have I in range of 4. That means I would be 0, 1, 2, 3, 3. That's it. So if I want 4 also, I would have to do 5. So there you go. 0, 1, 2, 3, 4 will be in range. And then if I try to create, I've created a new dictionary, and the dictionary key, in this case, the first time the for loop goes, the dictionary key is going to be DICT of 0. It's going to put 0 squared, which is also going to be 0. The next time the for loop goes over the range, it's going to grab 1. And then dictionary element of 1 is going to be 1 square is 1 again. And then third time it's going to go, it's going to get the value 2. So let's do it in our, why can't we do it in our sleep mode? I'm going to give it 5. And I'm going to say from time import sleep. That's all. And then instead of printing this, we can print it later. So there we go. So the range is going to grab, oh, it's printing all the dictionary. How about we print each dictionary element at this point? I'm going to print the dictionary here so we can see the dictionary changing at each single execution. So let's see, run, and there you go. Oh, it's printing this dictionary. So first it's grabbing the first element and adding. The second time it has the 1, 0, and the 1. The third time it has 0, 1, and the 2 in squared is 4. It's going to grab 3, and it's going to give me 3 is 9. And then the next time it goes over the for loop, it's going to do me 4 and 16. So basically, I've created this dictionary without this statement. So actually, I didn't manually create that dictionary. I made the range function define it for me. So when is this useful? When I have 20. If I'm asked to create 20 elements, of course, I'm not going to use sleep here. That's going to be a lot of delay. And then outside the for loop, if I print it, then it's going to give me all the 20 elements, 0 through 19, and then the squares of each. So this entire dictionary is created for me on the fly, but this is not using comprehension, right? So the comprehension, how would I do it? So remember, the new dictionary will always be on the left side, and then open, close, curly braces, because dictionaries have curly braces. And then we're going to put the for loop here on the left side, just like we've always done. Here, the only difference is you're going to have the key, and then you're going to have a value. So what is the value? So I is the key, and I square is the value. And that's about it. I think it's colon. There you go. So this is the key value pair. So each time it iterates 20 times, it's going to grab that's 3 lines of code all in one simple line of code. It will create the same dictionary. So dictionary comprehension, the only difference is you will have key colon value pairs. Let's take another example. So create a dictionary using 2 lists. So for example, I have 2 separate lists. So the header is like think of the Excel header. When you have the table column names at the top, you have names, CWID, major, GPA. And then let's say we have another list which actually has the values corresponding to these keys. So there's this student, who has all these values, and you are asked to create a dictionary. So without using comprehension, what you would do is you would take the student, create an empty student dictionary. And then you can go over this list or first, and then you're going to grab the index and the value. So index will be 0 in this case, and then the value will be name. And then the for loop goes over again. Index will be 1, value is going to be CWID, so on and so forth. So now to this dictionary, I'm going to create this key. So the value is nothing but name. So before I even do any of this, let me just display how it shows in the list. So I'm going to print the index and well, I'm going to put like this maybe. And then I'm going to print the val. And then I'm going to sleep for 3 seconds just to see what's going on here. What it did. Oh. Not print that anymore. So run. So it's going to go over the list. So 0 is name, 1 is CWID, and then 2 is equal to major, 3 is GPA. So I'm getting the index and the values. But for a dictionary, I don't need these anymore. The zeros, 1, 2, 3, I don't need them anymore. What I need for the dictionary is the name, CWID, major, GPA as the keys, and these are going to be my values. So very simply, what I did was to this dictionary, I'm going to grab the val. So what is the val in the first instance? It's going to be name. And then I'm going to take the student and I'm going to use this index. So what is the index of name? Index of name is 0. I'm passing that 0 to this list and it's going to grab the first element. So if I did that instead of, I'm going to simply print it. So while it is doing that, let me see real time what is going on over here. Okay, so run. First, it's going to grab 0 and name. What is the key value error here? Let me take a look. And just 1 second. So, sorry, I don't want to print the dictionary. I just want to print this student index. So what is going to happen? So it's going to get the 0 and the name, and it's going to also get the student at that index, which is 0. So basically, I'm trying to get these CWID and 100 because for my dictionary, that's what I need. So this val and this student index will be the key value pair for my dictionary. So very simply, I don't know why I grabbed that one. So that is going to be the dictionary index or the dictionary val. Val is going to be name because that's what it's printing here. For that, dictionary val is equal to student index. So I'm going to clear out all the prints and all the sleep statements. So now if I try to print the dictionary, it will tell me. So name is Suchi, CWID, C100. So basically I created my dictionary, but that is without comprehension. So with comprehension, let's go and see how we can do that. So student dictionary name will always be on the left. open close curly braces. Now, where is the index and where is the key? So we're going to find that. And actually, we are going to use a zip method here. So this is going to be slightly different in dictionary comprehension. So I'm going to grab that code. So without all this hassle, it's very simply, we're going to use a function called zip that zips the header and the student. So these two dictionaries, these two lists are zipped together and they become the corresponding key value pair. So the first element of header and the first element of the student become the key value pair for this dictionary. So on and so forth. So it will create me that dictionary. So another example I have given a few more examples so you can take a look and see what's going on there. I've added a little bit more complication. So we've seen how to create squares of keys. So key and a square of a key as a dictionary element. Here I'm saying cubes of keys, but the value should be divisible by 4. So how can we create a dictionary like that? Take a look at that example and try to execute it and see. So that's about all I wanted to do for this video.